Hello students. Now in second semester we start the next lesson number 11, reflection of light. First of all, can you recall what is light? And one more question given, what is meant by reflection of light? Which are the different types of reflection? So I will show the answer of these two questions. See there. First one, what is light? Actually, electromagnetic radiation which causes the sensation of vision is called light, and light is a form of energy. What is meant by reflection of light and which are the different types of reflection? That is the second question given. So first answer, reflection of light. When rays of light fall on any opaque surface, opaque means non-transparent, so they turn back. It's called reflection of light. There are two types of reflections. First one, regular reflection. Reflection from smooth surface is called regular reflection, or that type of reflection is a regular reflection. And second one, irregular reflection. Reflection from rough surface is called irregular reflection. So these are the two answers of that two questions. Can you recall? Come back. So next explanation given here, see there. Light is an agent which gives us information about what is happening in our surrounding. We can enjoy various wonders of nature like the sunrise, sunset, rainbow only because there is light. It is only because of light that we can see the lush green vegetation, colorful flowers, check here, colorful flowers, deep blue skies in the day, stars shining in the dark night sky, in the beautiful world around us. We see the man-made objects in our surrounding as well. So what is light? Answer is given here. Mark that. Light is actually electromagnetic radiation which causes the sensation of vision. Question asks for 1 mark. What is light? So you write like this way. Actually, electromagnetic radiation which causes the sensation of vision is called light. Getting all of you? Next. Light reflects differently from the various surfaces around us. We have already learned that the reflection from the smooth, flat surface is irregular. From smooth and flat surface is a regular reflection, and second type is already we explained, we learn in above question answer. While a rough surface reflects light irregularly, means that is an irregular reflection takes place from the rough surface. Clear? Next point is given here, mirror and types of mirror. So check that. Can you tell what is mirror? So already answer is given in this explanation. See there. We need polished surfaces for reflecting light. This is because polished surfaces absorb less light, and so maximum light gets reflected. In a scientific language, so answer is given here that you mark. What is mirror? Answer start from here up to here. A surface which reflects light and creates clear images is called a mirror. In short, a mirror is a reflecting surface. A reflecting surface is also called as mirror. We use various types of mirrors in our daily life. So, what are the types of mirrors? Question asked like this way. So, mirrors are of two types. First one is what? Plane mirrors. And second one is spherical mirrors. Little information given about here about the scientists and introduction to scientists. See there. The German scientist Justus von Liebig coated the plane surface of a piece of ordinary glass with silver metal and made the first mirror. Who made the first mirror? Who made the first mirror? So answer is given here. German scientist Justus von Liebig. Such a mirror is called as what? Silvered glass mirror, because on a glass surface coating of silver given by the scientist, and that's why that is called as silvered glass mirror. Next one, plane mirror. See in the figure or in the picture what is given. This is a plane mirror. All of you observe here. Question asked here for 2 marks. Write a short note on plane mirror. See the explanation. Plane mirrors are used in various activities in our day-to-day life. A mirror is made by coating the back surface of a flat and smooth glass piece with a thin reflecting film of aluminium or silver. Check here what is the explanation given. Second point is given here. A mirror is made by coating the back surface or any one surface of a flat and smooth glass piece with a thin reflecting film of aluminium or silver, any one. To protect this reflecting film and to make that side opaque means non-transparent, another coat of a substance like double underline lead oxide is given over it. This lead oxide coat is a protecting coat on that silver or aluminium film. So that surface is a opaque one and another side is act as a reflecting surface and form a plane mirror. Next, can you recall? Already you learn about this. What is the question given? What are the laws of reflection of light? So I will show the answer of this question also. See that. 3 points are given. Laws of reflection of light. What is the first point? Check. The angle of reflection is equal to the angle of incidence. Second, the incident ray. Second point, the incident ray, reflected ray and the normal all lie in the same plane. And third point, the incident ray and reflected ray are always opposite side of normal. Normal means perpendicular. So already you learn like this. This is a normal. Clear? This is a incident ray. This is a reflected ray. Angle made between this incident ray and normal. This angle is called as the angle of incidence, indicated as a small letter I. The angle made between this normal and this reflected ray, that is the angle of reflection. So this angle of incidence and angle of reflection are always equal in a regular reflection or in case of reflection. Next, come back to our main page. So this is the answer of this last question. Can you recall? What are the laws of reflection of light? Next page. Now see the explanation what is given here. We see a clear image of ourselves when we stand in front of a mirror in our house. Check in the figure also. To understand how an image is formed in a mirror, let us first consider an image formed by a point source. Light rays travel in all directions from such a source. Several of these rays fall on the mirror, get reflected and reach our eyes. Due to reflection, they appear to be coming from a point behind the mirror. That point is the image of the point source. Now, as figure 11.2a, this is a figure, shows light rays falling perpendicularly. Check, this is the plane mirror surface and these are the incident rays. After reflection, so angle is these incident rays fall on mirror perpendicularly. See here angle is formed. So perpendicularly on the mirror are reflected back in a perpendicular direction, means in the same direction, because these incident rays fall on the mirror in a perpendicular manner, that is 90 degree. Clear? Next, that is shown in figure also. Next one, as figure 11.2a shows, light rays falling perpendicularly on the mirror are reflected back in a perpendicular direction. Now second figure B, check here. This is a figure number B, this one. Figure 11.2b shows a point source O. Where is showing O? This is a point source O. Clear? Check. In front of the plane mirror M1, M2. This is the plane mirror M1 and M2. This is a plane mirror. These lines are showing here what? Coating, protecting layer of aluminium given on that side, or silver, anyone. Incident ray OR1, check that. I will show again. Here point R1 and second point is R2 here. R1 and R2. Point O is here. So OR1 and OR2 get reflected according to the laws of reflection along the path R1S1. So OR1 reflect from the point R1 in this direction. So R1S1, and OR2 is reflected in the direction what? R2S2. Check there in the figure. Getting all of you. So these are the reflected rays respectively. When these reflected rays are extended behind the mirror, so check here, these rays are diverged from each other like this. They never intersect to each other in front of the mirror. So we extend in a backward direction. They appear to meet at one point, that is indicate here O1. When seen from point E, check again. Where is the point E? Here. E point means I point. We are observing from this point E. When we seen from point E, the rays appear to the coming from O1. Appear to be coming from O1. Other rays starting from point O also get reflected and appear to be coming from O1. Thus, point O1 is the image of point O. Image of this point O, where the image is formed? At point O1. Clear? Next one. The reflected rays do not actually meet. These two reflected rays do not actually meet, and such an image is called as a virtual image. Mark this. What is meant by virtual image? The reflected ray never intersect to each other or actually meet to each other. So that type of image is called as a virtual. Virtual means not real. Not real image called as virtual image. So what is meant by virtual image? That is given here. The perpendicular distance of image from the mirror is equal to the perpendicular distance of the source from the mirror. Next, one more figure given here. Check that. Figure number C. If we use an extended source instead of a point source, such as one pencil showing here, this is an extended source, that is a PQ, keeping in front of this mirror M1, M2. An image is formed of every point of the source, thereby forming an extended image of the whole source. As shown in figure 11.2, see, an extended source PQ, that is one pencil is showing in the figure, is kept in front of the mirror M1, M2. The images of point P and Q are formed at P1, Q1. Image of the point P formed at point P1 and image of the point Q formed at point Q1. These distances are equal. These distances are equal from the mirror and inside the mirror, resulting in the image P1, Q1. This image P1, Q1 is formed. This is one extended object of the entire extended source. The image formed by plane mirror is of the same size as the source. Whatever the size of that object, here showing pencil. So same size object is a form here. Check now. Clear all of you? Next. Some basic question given for you. You recall the answers of these questions. First one. If we hold a page of a book in front of a mirror, we see laterally inverted letters in the mirror. Why does it happen? Explanation given in this above three figures. Yeah, this last figure C. And second, which letters of the English alphabet form images that look the same as the original letter? For example, if we are write capital A in a bigger font size on one paper, and that paper we are kept in front of the mirror, and you read inside the mirror, you read the image of this A in the mirror. See that? So A remains A, but second letter we are writing on the paper, and that paper you kept in front of the, keep in your hand and check this letter B is looking the same. Yeah, there is any difference. So in that way, how many letters are there in alphabet from A to Z, that is remains the same. You find out the answer by own. Perform this simple activity. Clear? Next. So next question. What is meant by lateral inversion? The image of a word appear laterally inverted in the mirror. So mark the answer from here. The image of every point on the word is formed behind the mirror at the same distance from the mirror as the point itself is called lateral inversion. Next. Again, use your brain power. Like these questions, you revise. When a person stands in front of a plane mirror, how is the image formed? Like the on previous page, that image of the pencil form in same manner the image of the person from here. And what is the nature of the image? So that image of any person in a mirror is not the real. So what is the nature? That is a virtual image. Getting all of you? On previous page given some examples with the help of figure. So you are find out the answer. Try this. Place two plane mirror at an angle of 90 degree to each other. Take two plane mirrors that is showing in the figure. Check now. That is showing in the figure. Check now. All of you observing? Yes. What is the angle between these two mirrors? 90 degree. Place a small object between them. Images will be formed in both mirrors. So how many images do you see? Perform this simple activity at home. Clear? Take two mirrors at an angle of 90 degree. Place one small object in between them and observe how many images are observed in both the mirrors. So your answer. So see here, we are observing the three images, 1, 2 and 3. Now change the angle between the mirrors as given in the following table and count the number of images each time. How is this number related to the measure of an angle? So first of all, we find out the answer. You have one question given. Angle is 90 degrees. Our answer is 3. Angle is 90 degree between the two mirrors. So how many images are formed? 3 images. So in this way, we are completing this table. Our first answer is 3. Suppose 120 degrees. So we are here given one formula. With the help of this formula, we find out the answers easily. N means what? Number of images. A means angle between the two mirrors. So what is the first angle? 120. So N is equal to 360 divided by A minus 1. So for 120 degrees, check there. So 360 divided by 120 minus 1. So 0, 0 cancel. 36 divided by 12. 12 1s are, 12 3s are. 3 minus 1. We are getting the answer 2. Only 2 images observed when two mirrors placed at an angle 120 degree. Then 60. Check that. When angle is 60 degrees, then find out the answer. 360 degree divided by 60 degree minus 1. So 1 0 cancel. 36 divided by 6 is equal to what? 6 minus 1. We are getting the answer 5. Clear? In this way you find out for the how many number of images formed when angle 45 and 30. That is for your homework. Complete the following table with the help of this formula. By using this formula, you complete this table. Next, check if the number of images that you obtain for different values of angles is consistent with the above formula. So we are getting the answer different. Clear? When the angle is 120 degree, then only 2 images form. 90 degree, 3 images form. And 60 degree, 5 images form. Find out these two also. Next, if we keep the mirrors parallel to each other, how many images will we see? Both the mirrors are parallel to each other like this way. And we are putting any one object in between these two mirrors. This is one object, clear? This arrow means one object. You put candle or any standing or any object and observe how many images in between these two plane mirrors. So our answer is infinite, uncountable images are formed. Confirm, perform this activity at home. So one important statement given to us. Remember, in order to see the full image of a person, standing in front of a mirror, the minimum height of the mirror must be half of height of the person. Means, what is the height of a person? Suppose 150 centimeter. So what is the height of mirror required for observing the image of that person whose height is 150 centimeter? So what is the half of 150? 75. 75 centimeter height of the mirror is required to that person when he observes his own image in a mirror. So that image is observed full body or full image is observed of that person. Proof is given. Small proof is given here. In figure 11.4, where is that 11.4? Check here. This is 11.4 figure. I will showing here. This is the size of mirror PQ. We are drawing the parallel lines. So PQ is a parallel to what? RS. Clear? This RS point. But RE means what? RE is, this RE distance is half of the HE. HE divided by 2. Then ES distance, ES is the what? Half distance of EF. Check that. This one. So EF divided by 2. Clear? Getting all of you? So denominator is same, so write only one time. HE plus EF. HE plus EF. Check here. Distance HE and EF. So we are getting the answer what? Whole distance HF. So denominator is same. HE, this distance plus this distance. HE plus EF means nothing but HF. So getting all of you. So we are getting the half distance here. See that proof on previous page. See the explanation. So in that figure 11.4, the point at the top of the head, the eyes, and a point at the feet of a person is indicated by H, E and F respectively. R and S are midpoints of HE and EF respectively. The mirror PQ is at the height of NQ from the ground and is perpendicular to it. PQ is the minimum height of the mirror in order to obtain the full image of the person. For this, RP and QS must be perpendicular to the mirror. Find out why by studying the figure 11.4. Minimum height of the mirror. We are confirming minimum height of the mirror. So PQ is equal to RS. But RS nothing but total RS distance means RE plus ES. So RS means what? HE divided by 2, half distance. ES means what? Half distance of EF. Denominator is same, right? Only one time, so 2. And addition of these two, HE plus EF means nothing but HF. Clear? So HF is what? Height of the person. The height of the mirror. So HF upon 2 is equal to what? Half of the person's height. PQ is given here. So PQ is equal to HF upon 2, that is equal to what? Upon 2 is means half of the person's height. So that much size required of mirror. Then the person observing his full image in that mirror. So in this way, today we learn about reflection of mirror, then mirror and its types, plane mirror, then laws of reflection, then what is meant by virtual image that is showing here, then lateral inversion, which letters are same and which are inverted, so lateral inversion definition is given here, and how many number of images form between the two mirrors when different angles are given here. With the help of formula, easily we find out the answers of all these. Clear all of you? Yes. Thank you.